The immigration in our countries, the natality rate has increased drastically, and this has created what we call population explosion. The high population rate has actually impacted negatively on our environment to the extent that our local, global, and our local, national and global ecosystems such as the earth has been affected, upsetting the food chains and the ecosystems, to the extent that life on Earth is actually being threatened. Some of the species have nearly become extinct. This has resulted in the depletion of the ozone, deforestation, acid rain, overgrazing, desertification, and global warming. We are now going to be looking at some of the key concepts on the human influence on the environment. We're going to look at the concepts, and thereafter these concepts will be elaborated at a later stage. We're going to be looking at questions. How do we deal with questions on these issues at a later stage? So first of all, let's look at deforestation. This actually is the removal of trees. How now does the removal of trees impact on our environment? If trees have been removed, that is obviously going to bring about global warming. And what is global warming? So now we are looking at deforestation, which is actually the removal of trees, resulting in a decrease in photosynthesis, causing an increase in the CO2 levels. How does that actually have a relationship with global warming? If you take the Earth, which is the first little circle that I'm drawing, and then we have the atmosphere around the Earth, and below the atmosphere, the CO2 levels rise, creating a blanket. Why do I say blanket? Because once we find the sun rays actually coming in through the atmosphere, most of the sun rays are reflected back into space. But with an increase in CO2 levels due to deforestation, the heat of the sun rays is trapped below the atmosphere, creating an increase in temperatures of the Earth, resulting in global warming. These two are very much and very closely related. The next key concept that we're going to be looking at is, why are alien species so successful? Alien, we're going to look at what is alien. We will come back to that later. Control of the invasive alien species. We're going to look at the control of invasive alien species as well, another key concept dealing with human influence on the Earth, as well as ozone depletion. Now, what I want you to remember is that deforestation, global warming, and ozone depletion are all very, very closely related terms on the environment. We're going to do it in great detail. How does each one differ from the other? Deforestation. The effects of deforestation. Natural forests are being cut down to grow food crops for the growing population, resulting in afforestation. Now here's a new term, afforestation and deforestation, terms that are very, very confused in an exam. Deforestation simply means removal of the natural forests to build homes, create farms, have industries, a whole lot of things that humans actually need for space, to remove the forest and create space for themselves. Now, afforestation simply means, in place of removing the natural forest, commercial farming of pine trees have now been replaced with the natural forest. So you have acres and acres of the same types of species like pine trees that are cultivated in order to produce paper. So when you see acres and acres of pine trees in perfect rows, that is actual commercial farming, which is actually known as afforestation. What is another effect of deforestation besides afforestation or commercial farming? We look at habitat destruction. Remember, there were natural predators, prey, birds, plants, all kinds of biodiversity that was living in the actual area, in that ecosystem. Now, by removing the natural forests, the habitats of those insects, birds, and plants have been destroyed. So therefore, man is now having a negative impact on the environment. Let's look at the next one, overgrazing due to subsistence farming. These two terms are very closely related to geography as well. So you find there's an interrelatedness between two subjects. Overgrazing is a result of human influence as man has to have more cattle for food. So therefore, he puts a lot of cattle to overgraze in a small area. And what will that cause? That is now going to cause soil erosion because of overgrazing. Once the soil is eroded, that means all the top fertile soil is going to be removed. Nothing, no plants can actually grow there anymore because the roots themselves wouldn't bond with the soil. All the fertile soil has been eroded. All the humus in the soil has been removed. Nothing more can grow there, resulting in desertification. Desertification is the total removal of fertile soil, whereby the land becomes completely barren to grow any more food crops for human use. What will that result in now? The destruction of food chains. Remember that when forests are removed and habitats are destroyed, you're actually destroying the food chains as well, because now you're removing the natural plants that the natural producers, the primary consumer now has nothing that for it to feed on. So if, for example, there were little mosses and the little ants used to feed on, with the felt fire and the removal of forests, now the pioneer species that used to exist have now been destroyed. So overgrazing, desertification, and destruction of food chains are now linked. I want you to remember that when you're looking at these concepts, that these concepts are linked as a human influence on the environment. You can actually write an essay and link them so that there is synthesis. How does deforestation lead to global warming? What is ozone depletion? How does deforestation bring about afforestation? How are habitats destroyed? And if habitats are destroyed, naturally our ecosystems and the food chains that exist in the ecosystem will also be destroyed. We now look at the imbalance in oxygen and carbon dioxide levels. Remember, as we stated firstly, that the removal of trees will reduce photosynthesis. A reduction in photosynthesis simply means that there's going to be an increase in carbon dioxide and a decrease in oxygen level, which is fatal for human life. Decrease in oxygen level is fatal for human life. Right, so let's now look at a sketch that actually illustrates to you the greenhouse effect. First of all, I want you to know, why is it termed the greenhouse effect? If you look at market gardeners that grow crops on a large scale, they need to grow crops for the growing population throughout the year. So if the temperatures are low, crops cannot survive. So these market gardeners have to create what we call a greenhouse. The house is not green, it's just basically plastic. And then the sun rays comes through the plastic. Remember, if you are sitting in a car on a hot day with all the windows closed, even if it's winter, you're going to enjoy it because the sun rays comes through and the heat of the sun gets trapped within the car. This is how these market gardeners' plastic houses work. The sun's insulation comes in with its heat and light, and then when the light needs to be reflected back, it is trapped by the plastic. The heat within the plastic house is retained, increasing the temperature within the house, And therefore, all the plants that are green are able to grow. Therefore, it's called the greenhouse effect. Let us now look at this in reality with the Earth's surface. If you look at this, this is the sun. And now you have the sun rays coming through the atmosphere, which is around there, onto the Earth's surface. Right, here's the Earth's surface. And then you find the sun rays are coming into the Earth's surface. Almost 99% of the sun rays comes in through the atmosphere, and then it's reflected back into space. It's reflected back into space. So some of the heat is absorbed by the oceans and the ground, and then it's reflected back into space. Now we need to know how does the greenhouse effect occur on the Earth, the globe itself. Remember, this is the atmosphere. And I told you before that the atmosphere, the carbon dioxide levels due to deforestation will increase around that area. So when the solar radiation comes in and it needs to be reflected back into space, it is trapped by this layer of CO2. And that is why now our temperatures have increased. So this is what we call global warming. Just to give you a brief explanation of global warming again, because these are very important concepts. Less trees means less photosynthesis, thereby increasing carbon dioxide levels. Remember, when you are answering an exam paper, to use the best biological terminology, because you get marks for using words like less trees, less photosynthesis. You are showing that there's a relationship between trees and photosynthesis. Increasing carbon dioxide levels. So that means for a question like this, it can carry about 4 marks. What is global warming? Or how does deforestation lead to global warming? And here you have an answer for at least 4 marks. What else do we need to know about global warming? Increase in carbon dioxide levels will prevent UV light from reflecting back into space. Increase in carbon dioxide levels. Why? Reduced photosynthesis. Now, that layer of CO2 is going to prevent the UV light, which is the ultraviolet light. It's a very hot ray of light that comes from the sun that cannot be reflected now back into space, thereby also increasing the global temperature. Here we have that increase in global temperature. So deforestation creates global warming. To summarize it, due to the layer of CO2 forming a blanket below the atmosphere. We now look at some of the effects of global warming. What are the effects of global warming on our Earth? Globally, nationally, locally, what are the effects? And we can see it in everyday life. We are able to see the effects. Effects of global warming, the loss of biodiversity. Just to explain, loss of biodiversity means certain plants have a certain temperature at which their life cycles continue. If the temperature drops or if the temperature rises, these life cycles cannot continue, causing a loss of that plant species. Remember, biodiversity refers to the variety of plant and animal species that are found on Earth, each one actually continuing its life cycle at a specific temperature. Therefore, global warming will affect biodiversity, creating a loss. There will be deaths in certain species. Loss of biodiversity automatically will affect the food chains. Climate change. You often hear of people saying, it's raining, there's too much of rain, or there's no rain, or there's floods. All this climate change is caused by global warming. The increase in global temperature also affects cloud formation. Cloud formation, wind patterns have changed, resulting in climate change. Now, global warming, automatically, if the Earth's temperature is increased, we're going to see the melting of the polar caps. If you look at the movie Ice Age, you would have seen how the ice is actually thinning and the animals can fall into the water instead of actually moving onto the ice. So the polar caps are melting, and this is a threat to human life, because remember, where the poles are, those masses of ice glaciers are actually a source of fresh water on Earth, where all the fish, actually the fish and certain animals depend. We need this fresh water. So although the ice floats on seawater, those ice glaciers are a source of fresh water. And melting of the polar caps threatens for all that fresh water to be lost into seawater. Then you have a relationship. Melting of the polar caps will cause a rise in the sea levels. Rising sea levels, what will rising sea levels actually do? The actual tectonic plates on which the sea rests cannot take the weight of the increasing sea levels, creating an earthquake under the sea called tsunamis. Due to global warming, we also have an increase in malaria. Because of the higher temperatures, because of all the water systems that are created around the earth, you find that the Anopheles mosquito, which is the main cause of malaria, have now a more favorable temperature for them to reproduce, resulting in an increase in malaria. Remember, at the beginning we spoke about some of the key concepts of human influences, and now we're actually looking at alien species. Why are alien species so successful? First of all, you need to know what is an alien. Please do not think an alien is out of space. An alien is basically, an alien plant or an animal is basically a plant that is not native to the land in which it is found. It's not native, it's not indigenous. So alien, invasive, means a plant that is not indigenous, it is not endemic, and it's not indigenous to that area, which means it must have been brought in from another country. How does humans do this? Remember, humans can carry seeds under their shoe. They can with deliberate intention, bring a plant that they would like in another country and smuggle it into their bags and then plant it into their own country. And this is actually a human negative influence that the plant is going to have on the environment. What are some of the alien species? The yellow oleander tree, which has actually beautiful yellow flowers, the weeping willow, and the hakea grass. These are 3 examples of alien species. Now, why are alien species so successful? The reason is that they have no natural enemies. There's nothing for there's no predators, natural predators to feed on these species. Therefore, they are able to reproduce very rapidly. They reproduce rapidly as they produce more seeds than the indigenous species. Remember now, there's no natural predators for them, nothing to feed on them. Therefore, they grow rapidly. More seeds are produced, and therefore, they will actually use up more water than the indigenous species, causing the indigenous species that are native to that land to die off. Another thing that makes them so successful is that they are tough and they can grow in even poor soils, soils that are brackish, probably barren soil. These plants are able to sustain themselves because they are alien and there's nothing to actually kill them naturally or feed on them. We're going to look at now how can man actually control these alien invasive species that have been brought onto our land or brought into a land. We're looking at basically 3 control mechanisms. One is a mechanical mechanism, chemical control, mechanical control, and biological control. As the name suggests, mechanical is where the trees that are alien have to be physically cut down and removed, like the weeping willow. Although there's many weeping willows, people use them for shade, they serve as nesting areas, but the thing is they are actually absorbing a lot of the water that is needed for the indigenous plant. So we have to physically fell the tree or cut down the tree. Chemical control, farmers normally, if they have the hakea grass growing amongst the mealie crops, then they are able to spray the mealies. We're using herbicides. Spray the mealies and kill them. Spray the hakea plants, hakea grass with herbicides and kill them and allow the mealies to grow. But The disadvantage, it's very expensive. It's a very expensive method. The best method to actually remove the alien plants would be biological control. As you can see, biological means natural life, natural enemies from the natural habitat. So research has to be done on wherever that plant came from, what could actually feed onto this plant? What fungus can I put onto this plant? What insect can feed onto this plant? And then you have that insect has to be you have to look at the alien species, and then you've got which is like the host, and then you've got to look at which biological control agent am I going to use to feed onto that alien species. There has to be host specificity, because if we're going to use a biological agent which not only feeds on that alien plant but feeds on the valuable crops, then it's going to affect the ecosystem in a negative manner. So therefore, biological control, we use natural enemies from the natural habitat. Example, insect and fungi used to kill the plant. It's a safer method for the environment, because with herbicides, remember, during rain, the herbicides run off into the water masses or the aquatic ecosystems, affecting the food chains there. So the best method would be biological control. The chemical method, the herbicides, are expensive, and then mechanical control, it's labor intensive. So the best method would be biological control, but research has to be done on what actual biological agent can be used to kill that invasive alien species. We are now going to look at a greater detail on what ozone depletion actually is. Ozone is a highly reactive, unstable gas, and is naturally found in the stratosphere. It is therefore not a pollutant. It absorbs a large part of the sun's UV light before it reaches the Earth's surface. CFCs from aerosols break down the ozone layer. Now that's a lot of information, so we just need to look at it gradually, one step at a time, what is going on in this whole explanation. First of all, ozone is actually made up of 3 atoms of oxygen, and it's unstable because it reacts very easily with other molecules. It is found 30 kilometers above the Earth's surface in a layer called the stratosphere. So 30 kilometers above the Earth's surface, that is where you would find the ozone. It's actually far above the atmosphere. It is therefore not a pollutant. It occurs naturally. It's a natural formation around our Earth, around our atmosphere. It looks as if it's a halo around the Earth. It's an invisible gas, but it feels like it's a halo. What does the ozone actually do? It absorbs a large part of the sun's UV light. Remember, the ultraviolet light of the sun is harmful, but the ozone layer renders it harmless. So as the UV light filters through that ozone, it becomes harmless once it enters the Earth's surface. Now, why is the ozone being depleted? It's simply being depleted because, remember, with modern technology, aerosols, the propellants from the cans, your air fresheners, deodorants, your air conditioners, your refrigerators, these are all parts of modern technology, man's modern usage of things. So what are these aerosols and deodorants and refrigerators and air conditioners actually releasing? They are releasing what we call the chlorofluorocarbons, abbreviation CFCs. It is actually the chlorine part that reacts with the ozone, causing the ozone to be broken down into oxygen and into 2 oxygen molecules and 1 oxygen atom. So that means that the ozone has been broken down. This thinning of the ozone has been noticed in the 1980s, right? Over Antarctica, it's more around the poles, because remember, the CFCs diffuse from the Earth's surface through the atmosphere into the stratosphere, and then Because ozone is a highly reactive gas, it actually collides with the CFCs, and then the CFCs break down the 3 atoms of oxygen, and then you find the ozone layer slowly becomes depleted. And this is where we've seen where the satellites have actually picked up the hole in the ozone layer, which is above Antarctica. Now, with ozone depletion, you find that the UV light comes through, it's very hot, and it's also going to have side effects on the human population on Earth. We are now going to look at some of the questions relating to the key concepts that we have discussed earlier on, so that you know how to fit these key concepts into a question. How do you actually answer it to get the best marks, to get full marks for the particular question? This question has been taken from paper 2, 2007, question 3. But just for your information, if you need to actually revise work on environmental studies, then you can look at the past grade 12 exam papers from 2008 until March 2010, where environmental studies was one of the topics tested in the grade 12 paper. So if you take paper 2 of the 2008 to 2010 March grade 12 papers, you'd find an abundance of questions on environmental studies. Just to now look at the question, this is a passage. South Africa has offered to slow the growth of its greenhouse gas emissions by 34% by 2020. The biggest producers of greenhouse gases in South Africa are Eskom, the producers of electricity, and Sasol, the producers of petrol and diesel from fossil fuels. Just to give you a background knowledge, that Eskom actually uses coal as a fossil fuel to produce energy in the form of electricity, and Sasol uses crude oil to produce products like petroleum, paraffin, your propane gas, just your gas cookers, the gas there. So Sasol is the one that's producing your gas and your paraffin and your petrol and your petroleum and your diesel, and Eskom is using huge amounts of fossil fuels of coal to produce your electricity. Both these industries, the Eskom and the Sasol, actually give off or emit large amounts of CO2 during the combustion process. Combustion simply means the burning of the fossil fuel is combustion to release that CO2 into the air. The first question, which is the most important greenhouse gas? Now we know there are various greenhouse gases, but the one that is the cause of global warming is actually carbon dioxide. Because remember, the basic element of your fossil fuels is carbon. So the gas that's released the most from the burning of fossil fuels will be carbon dioxide. So that's the most important greenhouse gas. Okay, we now look at question 1.2 relating to the very same passage. Explain why Eskom and Sasol produce the most greenhouse gases. As I've explained earlier, that Eskom and Sasol use fossil fuels to produce energy. Energy in what form? Obviously, Eskom is using coal to produce electricity, which is a form of energy, and that releases carbon dioxide. And Sasol uses crude oil to produce your petrol. And obviously, petrol emits carbon monoxide, and then you have nitrous oxide, and these two are also greenhouse gases. So that is how explain why Eskom and Sasol produce the most greenhouse gases. Both are involved in the production of energy by using fossil fuels, which are made up of carbon. Therefore, they release the most amount of carbon into the atmosphere. We are now looking to look at question 1.3. This is actually a management strategy, or a strategy that one uses to monitor the carbon dioxide emissions. You're a scientist who has been employed by the government to check that the target is reached. The target they are talking about is that 34% of greenhouse gases must only be released by 2020, which means it must be drastically reduced. Now, how is that scientist going to actually monitor or measure that amount of CO2? Briefly explain the methodology we would use to do this. Well, the scientist would first of all ensure that Eskom and CESOL is actually adhering to legislations on the greenhouse gases. They have to check that are they following the Kyoto Protocol. Now, please remember, the Kyoto Protocol was an agreement signed by countries, including South Africa, in a country called Kyoto in Japan, whereby these countries or the necessary stakeholders from the countries agreed that they would reduce the greenhouse emissions, they would reduce it. So this scientist needs to check now, are they adhering to the Kyoto Protocol? If they've signed the protocol agreement, the Kyoto Protocol, are they adhering to it? That's the first step. Secondly, he's got to measure. There has to be some form of a apparatus to measure the volume of CO2 released by these towers of Eskom and CESOL, and then compare it to the previous years. So that is one of those are the ways in which he is actually going to monitor the carbon dioxide emissions and check from the previous years what was the trend. Now in the recent years, after signing the Kyoto Protocol, adhering to legislations on the Environmental Act, are they adhering to it? And that's how he was able to monitor that the target is going to be reached by 2020. Okay, we're going to look at 1.4, suggest two strategies that Eskom and CESOL could use to reduce their greenhouse gas emissions. Remember, Eskom and CESOL, if they have to have a strategy, that would be a management strategy. And what they could do is to actually ensure that the gases that are produced from their towers are trapped. And then before it's released into the atmosphere, the carbon dioxide can actually be used to react with another compound that can make it harmless. For example, if you take sulfur dioxide is a gas released by coal as well, not just carbon. Remember, coal is a fossil fuel and it's quite hardened. It's a solid fossil fuel made up of different elements. Sulfur is one of them. So when coal is being burnt, right, remember that oil also comes from coal, which also contains sulfur. So when we burn these fuels, that's the oil by CESOL, the coal from Eskom, and SO2, which is sulfur dioxide, one of the causes of acid rain. This sulfur dioxide, before it's actually released into the atmosphere, they can actually combine it with calcium carbonate, or limestone, and then they can produce what we call calcium sulfate, which is very harmless, and that can be used somewhere else. Sulfur dioxide is one of the gases released by Eskom when electricity is being produced. Before the sulfur dioxide can be released into the air to actually combine with water to form acid rain, what will Eskom do? It can take the sulfur dioxide, collect it before released into the atmosphere, combine it with calcium carbonate, which is basically your limestone, and then chemically it will react to form harmless calcium sulfate. So in this way, we are preventing acid rain, and the amount of the amount of SO2, sulfur dioxide, as a greenhouse gas will be reduced. The second strategy that Eskom and CESOL can use is looking at alternative forms of energy, alternative forms of producing energy in the form of electricity. For example, they could use wind energy, where windmills are used. Solar energy, which is, we have the abundance of solar energy in our country in South Africa, long hours of sunlight. They could use solar energy as an alternative form of energy to produce electricity. And that is why now the government is actually subsidizing people who install solar geysers. And you know that a geyser in the home uses abundant amount of electricity, and large volumes of coal is produced. So if they can actually use alternative forms of energy or introduce the solar geyser as one of the most important means of a heating system in the homes, and that has to be a must, that is one of the ways that they're going to reduce the amount of coal produced burnt to produce energy, electricity. So what are the two strategies again? They can look at alternative forms of energy, solar heating, or solar energy, wind energy, nuclear energy, or they can use and introduce solar geysers, which uses a lot of electricity. And then the second strategy is, before these harmful gases are released into the air, they can allow them to combine with another compound, and then these gases can be rendered harmless. For example, sulfur dioxide plus limestone will give you calcium sulfate, and in this way you get a harmless compound that's forming and no negative influence on our environment or on the air that we breathe. We now look at question 2. And this is actually a data response question. Remember, data response is information given to you either in the form of a graph or in the form of a table, and you've got to interpret that table and then look at the questions relating to that data on the table. Question 2.1. Comment on the ozone depletion during the period 1982 to 1996. Right. Before we go on to the answer of that question, remember that the Montreal Protocol, that was also an agreement whereby countries have come together to ensure that they do not manufacture appliances and aerosols that release CFCs. So remember, the Montreal Protocol differs from the Kyoto Protocol. The Montreal Protocol was there to ensure that CFCs are not released into the atmosphere, or there's no more production of CFCs found in aerosols that can contribute to the ozone depletion. And the Kyoto Protocol is to ensure that industries reduce the carbon dioxide emissions, or the greenhouse gas emissions. Now let's look at the question. Amount of ozone depletion of stratosphere between 1982 and 1996. Remember that you have two columns. The first column here is your year, right? And normally what appears in your first column is actually your independent variable. That normally forms your independent variable, and it goes onto your x-axis if you have to draw a graph from the table. Secondly, you have your ozone depletion, and that one is normally your dependent variable. And that goes on your y-axis. Why is the one in the second column, normally the items in the second column normally change. They vary. It depends on the independent variable. So because it's varying, it's not controlled, it forms your dependent variable, and the independent one is normally controlled. You can control the years in which you are doing an investigation, but you cannot control the amount of something that's released or being depleted. Right, let's look at the question one more time. Comment on the ozone depletion during the period 1982 to 1996. In questions like this, what the examiners want is they want you to describe a trend. They want you to describe the trend over those years. And let's look at the trend. 1982, the ozone depletion, remember the unit is in tons. So in tons is actually the unit, right? 2000, and if you look right to 1996, it went to 7,000. So how are you going to describe it? In 1982, the ozone depletion was 2,000 tons. There was a slight increase in 1984 to 1986. And then there was a slight decrease in 1988. Obviously, after the Montreal Protocol was signed, then countries have adhered to that protocol, saying we will produce less CFCs. Thereby you can see there's a decrease in ozone depletion. Less CFCs were produced at that point. And then suddenly it increased again in 1990 to 1992 to 1994, and then decreased in 1996. So you've got to describe that in 1982 to 1986, there was a gradual increase in tons of ozone depletion. It decreased in 1988 after adhering to legislations. And then some of the industries did not adhere to legislations, and obviously the ozone was depleted again because the number of appliances, aerosols that were manufactured were not ozone friendly. They had CFCs in them. And remember that CFCs, once they float into the stratosphere, they continue to remain there and continue to destroy the ozone layer long after, even if industries have stopped the manufacture of aerosols with CFCs. These CFCs have long been into the atmosphere, diffusing into the stratosphere, and they continue to destroy the ozone layer. So although they have stopped, their CFCs were continuing to destroy the ozone layer, and only after 1994 there was a slight decrease in ozone depletion. So you've got to describe that trend. This year there was an increase, then there was a decrease, and then there was a slight increase again, and then a decrease again. So that is the trend. So you get marks for stating the years and whether there's an increase, decrease, and then whether there is stability. So that's how you will describe or you can comment on this trend. Let's look at the next question. The next question is based on the same set of data. Question 2.2, how much of the ozone was lost from the stratosphere in 1990? Now, for every paper that you get, even if you go to grade 12, there has to be a calculation. You need to know basic mathematical calculations. They do not need a scientific calculator. It's basic calculations that you need to do using the basic numerical, mathematical skills. How much of the ozone was lost from the atmosphere in 1990? So you've got to look at 1990 and check that there was 6,000, how much of ozone was lost from the stratosphere in 1990? All you've got to say is 6,000 tons. So here there's no calculation. It's how much for 1 mark? 6,000. But now, just 6,000 on its own wouldn't get a mark. It's 6,000 tons. And that will earn its full mark of 1. 6,000 tons of ozone was depleted in 1990. Let's look at the next question. CFCs can stay around for about 100 years. That means the CFCs that could have been released in the 1900s could still be there in the year 2000. Right. What is the implication of this for the ozone layer? That means that as long as the CFCs are around the stratosphere, they will continue to react with the O3, with the ozone, and continue to deplete it, to thin it out, and to destroy the ozone layer. So these CFCs that are released are going to continue destroying the ozone layer. And that is the answer for that. They will, the CFCs will continue to destroy the ozone layer. They will continue to destroy it. Let's look at the next question. Question 2.4. Give one possible reason for the decrease in ozone depletion after 1994. Right, you remember that once the Montreal Protocol was signed, so you can say that the industries, the manufacturing industries have adhered to the Montreal Protocol to reduce the CFCs that they have formulated into their cans. That's the one, adherence, so that means they're adhering to the Montreal Protocol. The second one could be, although asked for one reason, another reason could be they are adhering to legislation, which is the Environmental Protection Act. So you know that every citizen, in the Constitution of South Africa, every citizen has a right to a safe environment, safe drinking water, and safe air to breathe. Therefore, they have to adhere to these legislations. Otherwise, penalties or fines will be imposed onto these industries. So now, adhering to legislation, adhering to the Montreal Protocol, therefore you can see now that the ozone layer is now slowing down from depletion. It's being depleted in a smaller quantity. Okay, the next question. We now go on to question 3. Question 3, it's adapted from the June 2006 paper 2, question 3, if you want to go and refer to that. Now let's look at the question. The dying of trees due to acid rain is brought about by changes in the pH of the soil. Seppo observed that trees in his town were gradually dying. He decided to investigate the effect of acid rain on the germinating bean seeds. He did the following. Placed cotton wool on 6 saucers, poured a solution with a different pH, varying from pH 2 to pH 7, onto the cotton wool in each saucer. He placed 50 bean seeds onto the cotton wool in each saucer, covered the seeds and left them on the shelf for a week. The following results were obtained. Now that we read this important information given to us, and before we proceed to look at the data, we've got to analyze. Remember, by analyzing these statements, they have very valuable information which can contribute to some of the answers. Why, for example, did Seppo place cotton wool on 6 saucers? That means he had 6, he had 3. Remember, 3 for the experiment and 3 for the control. He poured a solution with different pH. Remember, pH means the acidity and alkalinity levels of a solution. So pH refers to acidity and alkalinity. Remember, why are we talking about a question like this with regards to human influence on the environment? As we said earlier, sulfur dioxide released by the exhaust fume, sulfur dioxide released from the burning of coal, actually reacts with water vapor in the air to create sulfurous acid, which forms part of acid rain. So if we have acid rain coming down, obviously the germination of seeds and crops are going to be affected. So that is why we are going to see the effect of acid rain. What effect does acid rain have on the germination of seeds? You have done an experiment similar to this in one of your SBA tasks, and now we're having a question relating to a similar, that is very much similar to those tasks. He placed 50 bean seeds onto the cotton wool in each saucer. So the variables means the factors have a constant, 50 bean seeds in one saucer, 50 bean seeds in the other saucer. He covered the seeds and left them on the shelf for a week. Obviously, he allowed for germination to occur. So you've got to analyze the statements. Now we look at the data on the table. Remember that low pH, pH of 1 and 2 and 3, the pH is low, but it actually signifies a high acidity. So low pH means high acid levels. High pH indicate a very weak acid. So low pH are strong acids, and high pH are weak acids. So if you look at pH 2, it's actually a strong acid. And if you look at pH 7, now you know the pH scale ranges from 1 to 14, so obviously a pH of 7 is going to be neutral. But a pH of 5 and 6 is going to be relatively weak. It's going to be weaker acids. So these are your weak acids, weaker acids. So before rushing off to answer the question, you've got to analyze the data that is given to you in the table. So strong acids and weak acids, and now we look at the number of germinating seeds. When there was a strong acid, when he placed the seeds in a strong acid of pH 2, none of the seeds germinated. When he placed them in a pH of 3, 4, germination started. But as pH became weaker, you can see that the number of germinating seeds have increased. So seeds germinate at weaker acid levels. That means when the pH is higher, the germination of seeds increases. So what are we talking about here? We are now talking about a relationship between the effect of pH on germinating seeds and this forms a very important relationship during an investigation where we can now formulate a hypothesis. Remember that a hypothesis is a statement of a prediction of a result coming from an experiment. So if you have if you're going to design an experiment, before you design an experiment, you have to observe. So what Seppo noticed, Seppo wanted to find out what effect does acid rain have on germinating seeds in nature. So he decided to design an experiment because according to him, he probably said acids have an effect on germinating seeds. Acids have. Some of you can, within your class, you can say, okay, low acid level or low pH increase the germinating seeds. Another can say low pH decrease the germinating seeds. Another one can say low pH has no effect on the seeds that are germinating. So you have 3 different hypotheses. Now you've got to go about in designing an experiment to investigate which of these hypotheses would prove to be true. Which of these hypotheses will be rejected according to the results. So Seppo decided to design that experiment keeping the variables in place. And remember what I told you earlier, that all the items in the first column forms your independent variables. You can control them. You can control the pH that you want to expose the seeds to. But you cannot change the number of seeds that are going to be germinating. So that is your dependent variable. So number of germinating seeds dependent, pH independent variable. Relationship between the two now of your prediction forms your hypothesis. Right. So let's look at the question now. Now look how easy your questions become. Name the independent variable in this investigation. You look at your data in the first column. That's what I can control. So my independent variable will be my pH level, or just pH, and you get a mark for that. Okay, let's go to the next question. Name the dependent variable in this investigation. And obviously this is a piece of cake. You know that dependent is what changes all the time. You cannot control it. So your dependent variable will be the number of germinating seeds. Number of germinating seeds. And that's 1 mark. And not just seeds, but number of germinating seeds will be your dependent variable. Right, so let's go to the next question. Question 3.3. Name 2 ways in which the investigation could be improved to obtain accurate and valid results. Now, Seppo cannot just do this investigation once and rely on those results. For those results to be reliable, what can he do? How can he improve the results to ensure that whatever results I have is actually valid, it's reliable? So the first thing he needs to do is, right, he needs to repeat this investigation. Whatever seeds he's used there, the number, he's just got to repeat it once more. So he's got to repeat the investigation using the very same seeds. Not the actual same seeds he used in the first experiment, but if he used daisy seeds, he would use daisy seeds. If he used 50 daisy seeds, he will again use 50 daisy seeds. So he will repeat the investigation. And then he would compare his results. So he'll repeat the investigation and he's going to compare the results between the two. And if he gets similar results, he can obviously take the results and look at them and say, no, these results are the same, so now these results are more reliable. What else he can do to ensure that his results are that his hypothesis, that his investigation is valid, he can actually repeat the investigation at a later stage, but he can use different types of seeds. So now he's repeating the investigation using different types of seeds. Because remember, in nature we don't have one type of plant, we have many types of plants and many types of seeds. So he can repeat the investigation using different types of seeds. And that's where he will get his mark. Repeat the investigation and then compare the results. Repeat the investigation using different types of seeds. Okay, so this is now where, please remember, when you get an example like this in your exam paper, they can also ask you to design hypothesis, and you could say that low pH levels decrease the number of germinating seeds. And if you look at these results, you can see that low pH levels, that means strong acids, do have a negative influence on the number of germinating seeds. And obviously, high pH levels, which means it's going more towards alkalinity or the acid becoming weaker, or high pH levels increase the number of germinating seeds. And remember, the acid that we are talking about in nature is the acid rain that actually has disastrous effects on germinating, kills the germinating seeds. It actually erodes through umbrellas. It actually has an impact on the bricks. It causes corrosion. So acid rain can harm living organisms, can even kill the ants. So we are looking now how human, indirectly, you look at the acid rain, but who is the cause of your acid rain? Remember, the carbon footprint is how much of carbon are you using in your daily lifestyle. The more lights you put on, remember, the more coal is needed to be burnt, the more carbon dioxide you're producing. Right. If you are going to be using a car every day on your own, just one person to travel, instead of using a public transport system, you actually have to use more coal to produce more petrol, use more coal to produce oil, or oil to produce more petrol, and therefore you're releasing more carbon monoxide into the atmosphere. So all these gases are indirectly as a result of human influence, human activity that is causing a negative impact on our environment. So we are looking at the table. You look at what is the hypothesis, you design it, look at the results, and if I said my hypothesis was low pH decreases the number of germinating seeds, and now I look at it after my investigation, I can come to my conclusion that high pH levels, the number of germinating seeds were 28, but when the pH level was 3, it was only 4. Therefore, according to my results, my hypothesis has been accepted. So that is hypothesis testing. These are dependent, independent variables, and how acid rain relates to the environment and how human influence is a contributor to acid rain, not directly, but indirectly by using more energy. More coal has to be burnt and more gases released into the atmosphere, causing acid rain. Let's now look at the next question. Okay. .4, describe the relationship between pH and the number of germinating seeds. I told you, every hypothesis has to have a relationship between what? Between your dependent and your independent variable. That is the relationship. We want to see a relationship between the two dependent variables, between the two variables, that's your independent and dependent. Describe the relationship, and how will you describe this, the actual trend? You would say that low pH levels, or as the pH levels increase, the number of germinating seeds also increase. So as the pH levels increase, the number of germinating seeds increase, which means that strong acids negatively influence germinating seeds. Weak acids have a positive influence on the germination of seeds. So the relationship between pH and the number of germinating seeds, for 2 marks, low pH levels decrease the number of germinating seeds, and high pH levels increase the number of germinating seeds. And that will give you, here it's 2 marks, but that can actually go up to around 4 marks. Okay, low pH, increasing germinating seeds, high pH, increasing the number of germinating seeds. So that can give you a total of 4 marks. The next question, 3.5, suggest 3 strategies that the government can use to help reduce the formation of acid rain. Now would you think, Acid rain comes from the cloud. How possibly can the government reduce the acid rain? But yes, he can actually reduce the acid rain by imposing certain laws, imposing certain penalties. And what are some of the things that government can do to ensure that humans don't negatively influence the environment and contribute to acid rain? The first thing that he can do, the first strategy is that the government, like in London has the best public transport system in the world. Okay, so South Africa has to learn from this, have an improved public transport system whereby at least 10 people can get into a car or into a taxi, into a bus. So the more people that get into one vehicle, you know, there's just one exhaust fume releasing that carbon monoxide into the air instead of 20 people driving to the same destination. So therefore you can use an improved public transport system. The government can improve the public transport system. Now remember that although we have 3 marks, sometimes in an exam paper, although they're asking for 3 strategies, the marks will be 6. And many learners lose marks. Why? Because whenever you have a statement, you've got to qualify your statement. Why? How is the improved transport system going to help prevent acid rain? Remember, if the public transport system is improved, there's going to be less vehicles on the road. Less vehicles on the road, less not only means less traffic congestion, but it's going to mean less sulfur dioxide and less carbon monoxide being released. Because once these 2 gases are released into the air, they react with the water vapor in the air to form acid rain. So improved public transport system, less vehicles and less emissions of these greenhouse gases. Another strategy what the government can do, and in South Africa it has already begun in 2003, where the government has ensured that introduced the lead-free petrol. Because the new cars now must only use lead-free petrol. So the introduction of cars use unleaded petrol or petrol that is lead-free. Because remember, lead also contributes to the formation of acid rain. So lead-free petrol. Also, the new cars are now having catalytic converters. So the government is now purchasing cars from overseas that have been installed with catalytic converters. Catalytic converters, that's spelling, C-A-T-A, catalytic converters in cars. Now obviously you've got to qualify that statement. Catalytic converters in cars, why? Because the catalytic converter in the cars converts nitrous oxide, which is found as a gas released from the combustion of petrol. It will convert nitrous oxide into harmless nitrogen and oxygen. And obviously nitrogen is a gas that is in the air that we do not use. A stable gas, and it will have no effect on our health and no effect on the formation of acid rain. So the catalytic converters in the cars convert nitrous oxide into harmless nitrogen and oxygen. The lead-free petrol ensures no release of toxic fumes into the air. The lead-free petrol, how will that contribute to a reduction in acid rain? Remember, petrol that has lead in it will result in toxic fumes being released, and unleaded petrol will prevent toxic fumes from being released, thereby reducing air pollution. Right. Another strategy that can be, a 4th strategy that can be imposed by government would be to ensure that the Environmental Act, which is a legislation, is adhered to by the various industries, by Eskom, by Sasol, and non-compliance to this legislation will actually, the government can impose heavy fines or penalty. Remember, fines and penalties go together. Legislation is different and fines and penalties are different, but both of these are important in actually allowing companies to adhere to the Environmental Act and reduce air pollution indirectly. We now go on to question 4, which is related to the alien invasive species, a line graph relating to that. Right, here we have the graph below shows the effect of biocontrol, which is basically your biological control, on an invasive alien plant population. So this is a graph showing there's a population size. Let's look at on your y-axis. It shows this is the population size of your biocontrol agent, which is the dotted line. So the dotted line indicates your biocontrol agent. And then obviously, and the other one is your target population. That's your target population. And let's put the solid line as your target population. So that's your target population there, that one. And this one is your biocontrol agent. Right, now once they've introduced the biocontrol agent, remember we said we can use fungi, we can use a different form of an insect that feeds on this, that is naturally a natural predator of this invasive alien species. We can use these natural enemies and they become your biocontrol agents. We introduce them into that ecosystem, and at that point where it's introduced, you find here is your alien invasive species now. That's the target group. And once you introduce this biocontrol agent that feeds on this invasive, that target species or that invasive alien species, the numbers drops without having any side effects on the environment, because it's going to feed on that alien invasive species only and not on the other healthy plants and animals that live in that ecosystem around that invasive alien species. Okay, so now we've interpreted the graph, and you can see this is time. Time is your independent variable. Population size is your dependent variable. Now let's look at the question. 4.1. Explain what is meant by the term biocontrol. And if we go there, biocontrol is a measure. It's a mechanism measure using natural enemies to feed or kill off the invasive alien species. Okay, so it's a measure using natural enemies to feed or kill off the invasive alien species. That is biological control, and this has a great advantage as it does not influence our environment in a negative way. Let's look at the next question. 4.2. Give 2 reasons that you can see from the graph to support the fact that biocontrol has been successful in controlling the alien plant population. Now, if you look at the graph itself, you'd see that the target population was around that point, and once the biocontrol agent has been introduced, you find that the target population, that is your alien invasive species, as well as your natural enemy, the population numbers are almost on the same level. The increase and the decrease are on the same level, like a predator-prey relationship. So which means now the one is not overpopulating the other. Now the levels seem to be almost the same. And that is how you know that the both are in harmony. The one is not exceeding the limit and destroying the environment. So give 2 reasons that you can see from the graph to support the fact that biocontrol has been successful. 2 reasons has been successful in controlling the alien plant population. And the answer will be, the first answer you can put is that the number of, or the size of the alien or target population. What happened to it? It decreased as soon as the biocontrol agent was added or was introduced. Right, so the number of alien or target population, or the number of alien species or target population, decreased as soon as the biocontrol agent was introduced. And the second reason for the successful introduction of controlling the alien species would be that the numbers of the alien species or the target population, as well as the biocontrol species, are almost the same. After the biocontrol was added. So let's go through it again. How do we know that the biocontrol was actually effective in reducing the alien invasive species? The number of the alien to target population decreased as soon as the biocontrol agent was introduced. So you say the number was decreased as soon as the biocontrol agent was introduced. The number of alien species as well as the biocontrol species were almost the same after the biocontrol was added, or the increase and the decrease of both were similar. That could be an alternative. And that is how you can see that they are successful. We go to the next question. Why is host specificity? If you remember at the beginning, when we discussed the alien invasive species, we spoke about host specificity. And that is, for example, if you look at viruses, the mumps virus is specific to, it will actually only target your salivary glands. It wouldn't target your eyes or your ear, but it will be specific to targeting the salivary glands only. The AIDS virus is specifically targeting your white blood cells. So in the same way, you need to find a natural enemy that will target that particular alien invasive species and not any other plant or animal species that's endemic to that area or that's indigenous to that land. So host specificity is very important when using biological control as a method of controlling your alien invasive species. So why is host specificity so important when introducing a biocontrol agent? And that is to ensure, and that gets a mark, to ensure that other natural or native plant and animal species that are indigenous to that ecosystem is not destroyed. And where are marks actually allocated? To ensure that other natural or native plant species, right? Natural or native, that could be a slash there, natural or native plant species or animal species, and you get a mark for animal as well, that are indigenous to that ecosystem, is not destroyed or not harmed. And that is very important. So there needs to be host specificity. This now brings us to an end on the human influences on the environment. And with it, remember, I've not only pointed out the content to you, but also the necessary skills of how to actually look at finding a dependent variable, independent variable, how to analyze a graph, how to analyze the data, and not just jump at answering the question. Please read the information that is given to you. Okay, know what is hypothesis. Remember that hypothesis again, when many children lose marks, it is a relationship between the variables and it's a prediction of what the results will be after an experiment using those variables. Also very important to remember is that if you look here, it's very important to, if you just look at the last question, to actually label a graph. If you go back to question 2, okay, question 3, let's look at question 3 one more time. All right, if they have to ask you a graph, to draw a graph using the data from this table, remember that you would put pH on your independent variable, number of germinating seeds on your, and then slot in regular or proper intervals. You wouldn't use the very same data listed on your table, but you'd look at the lowest, you'd look at the highest, and decide what will be my regular intervals. It could be 5, 10, 15, 20, 25, 30, 35, and not 0, 4, 10, because that will give you an incorrect scale and you would lose marks. Also the pH, make sure that you use a ruler to actually plot the intervals. Make sure you slot in units next to your labels. Make sure you use a ruler to actually join the dots and not use a free hand, because then you're going to get inaccurate results. So these are some of the skills that you need in answering the questions, right? And then you look at also terminology. When you are doing a section, slot in all the terms, acid rain, what it contributes, have like little concept maps around, actually concept mapping that you can do. If I can just show you something. For example, if you're talking about acid rain, and acid rain is like your main theme, then you can make little rings when you're studying on saying it's pH, and pH is it's actually low pH, okay? And then this is caused by, for example, sulfur dioxide, negatively affects germinating seeds. So little things like that around basic concept, ozone depletion, and then you talk about the CFCs, the ultraviolet light. So these little concepts will help you build within your mind a clear picture of the content listed under that particular topic, human influences on the environment. Look at where the links are, and then terminology will automatically follow. And then remember, when you have to draft an essay or do an essay, you are able to get, you must be able to get marks for synthesis. And synthesis, most learners going to write synthesis as something, write the definition of synthesis. Synthesis actually means where you take into account all the facts that are relating to the topic and put it into a nice flowing essay with the proper biological terminology slotted into place. And you can do that if you get your concepts right. Okay, so from me, I hope that you've learned a lot from this session, and we will see you the next time. Please remember to study well and make a list of your vocabulary relating to the topic, and you will do well. Thank you.